In this video, this is the worksheet we're going to be doing. We're going to be using the balancing equations worksheet on the front side. I've gone through all 10 of these. I'm going to show you a couple tips and tricks so you know how to balance the equations. Hopefully these help you out a little bit and you can do the back side of this page by yourself. So let's give it a go. Alright, we're going to learn how to balance equations today, and we're going to start with this one, which is methane plus oxygen yields CO2 and H2O. The first thing that I'm going to do is I'm going to make a list of all of my elements. I'm going to count how many of each of those elements I have in the equation above. Now that I have a list, I'm going to compare the number of carbons that I have on both sides. I have 1 on each side, so that's good. We have the hydrogens. I have 4 on the left, or the reactant side, and only 2 on the product side, so that's not good. And oxygens, I have 2 and 3. I'm going to leave my oxygens for last for 2 reasons. One is the oxygen is in 2 places on the product side. And second, because I have an even and an odd number. So the 2 is even and the 3 is odd. And I'm going to hope that they even themselves out. Always working on the side that is lower. So I'm going to work with the H's. On this side, hydrogen is lower, as a 2. I'm going to put a number here in the coefficient spot that when multiplied by the 2 that's here, right there, where my pointer is, what number times 2 is going to give me this number that's over here, which is 4. And of course, the answer is going to be 2. So when I put a 2 there, I am going to scribble out all of these numbers, and I'm going to recount everything that's on this side. 1 carbon, 2 plus 2 more oxygens is 4 oxygens, and 2 hydrogens. Okay, I went ahead and I wrote in those numbers. I recounted the carbons. Okay, let me find my pointer again. My carbons, I had 1 carbon. I had 2 plus 2 more oxygens, which is 4 oxygens, and 4 hydrogens. Now, lucky me, these oxygens evened up, so I've got an even number here and an even number here, which means I can multiply this 2, the subscript 2, by a number that's going to give me this 4. And of course, that number is going to be 2. So when I do that, these numbers go away. I'm going to recount 1 carbon, 4 hydrogens, and 4 oxygens. Now let's double check and make sure everything is balanced. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. Remember, when you balance an equation, if there is nothing written in this coefficient spot, it is a 1. And you do not need to write those 1s in, so we'll leave them out. So technically, I have 1, 2, 1, 2. What they're going to ask you to do is to sum the coefficients, which means add the coefficients, and you must add them as a 1. So the sum of the coefficients in this case is going to be 6. Okay, this balancing one is very simple. They gave us sodium and chlorine ions on the reactant side, and they gave us sodium and chlorine on the product side. The charges mean nothing in this case, so I'm just going to count everything up. I've got 1 sodium, 1 chlorine, 1 sodium, 1 chlorine. Everything matches, and so therefore all of my coefficients are 1. And my sum of my coefficients for this reaction would be 3. Alright, in this question we're going to balance aluminum plus oxygen gives us aluminum oxide. First thing I'm going to do is I'm going to make a list of all my elements that I have on the left side of the reaction. I have aluminum and I have oxygen, and on the product side I also have aluminum and oxygen. Remember that we want to keep these in the same order to make our comparison much easier. And then I'm going to count. I'll get a pen out again and I'll do it in red. 1 aluminum, 2 oxygens, 2 aluminums, 3 oxygens. Alright, I'm going to balance the aluminums first. So when I do that, I'm going to work with the aluminums, but I'm going to work with the side that is smaller. So aluminum 1 is smaller than aluminum 2. I'm going to put a number here that when multiplied by this subscript is going to give me this number. And in that case, it's going to be 2. So I'm going to go ahead and I'm going to put a 2 in for that aluminum. Once I put a coefficient in there, I have to erase or scribble out those numbers and recount. 2 aluminums, and 2 oxygens. Now I've got to go ahead and I got to fix the oxygens. Working on the side that is smaller doesn't necessarily work in this case because I need to find a number that will multiply to 3. So there's 2 ways we can do this. We can find a number that when multiplied by this 2 is going to give me 3. In that case it's 1.5. Or we can find the lowest common multiple of 2 and 3, which is going to be 6. So if I find the lowest common multiple, what number times this 2 is going to give me that 6? And that answer is going to be 3. So I'm going to recount everything, 2 aluminums and 6 oxygens. Now let's go to the other side, this side, and I have to make this oxygen into a 6. So what number here that multiplied by 3 is going to give me 6? And of course the answer is 2. And so I put that in. And when I put that in, I have to recount everything again because now I have 2 times 2 aluminums, which means I have 4 aluminums, and I have 6 oxygens. Now I have to go back and I have to fix the aluminums. So I'm going to change the color. I'm going to go ahead and I'm going to change this 2 to a number that when multiplied by this subscript of 1 is going to give me 4. So I'm going to put a 4 there. And I'm going to recount everything. 4 aluminums and 6 oxygens. All right, let's take a look at this question. In this question, we're doing nitrogen and hydrogen yields ammonia. There's a couple things I want you to be aware of with this question. Just as a little bit of a review, this nitrogen has a subscript of 2 because it is diatomic. This hydrogen has a subscript of 2 because it is diatomic. There is no subscript of 2 here for this nitrogen because that nitrogen isn't a compound. It is not considered a diatomic element. It's not an element, it's a compound. And these subscripts come from the oxidation numbers. This is a +1, this is a -3. And when I cross them down, I got a 3 and a 1. So it's just kind of like a little side note. Now let me erase that stuff so that it's out of our way. But we have to balance this reaction. First thing I'm going to do is I'm going to make a list of all my elements. And then I'm going to make a count for each. On the reactant side, I had 2 of each nitrogen and hydrogen, and on the product side, I had 1 nitrogen and 3 hydrogens. All right, I'm going to start with the nitrogens first because I always start with anything other than hydrogens and oxygens. So nitrogen looks like a really good place to start. You can see that on this side there's a 2, and on this side there's a 1. So I want to get this 1 to be a 2. So I go up to the product side of my reaction. This nitrogen has a subscript of 1. What number can I put here that when multiplied by 1 is going to give me this number over here? This number, the 1, doesn't matter anymore. Once I put a number in front of that ammonia, that 1 doesn't exist. So I'm going to take black. I'm going to put a 2 in front of there. When I do that, I recount. I have 2 nitrogens and 6 hydrogens. Now let's deal with the hydrogens because the hydrogens are not the same. So I'm going to work on the side that's smaller, in this case the 2. That means I'm working with this hydrogen, which is on the left side. That's the only thing that it tells me is which side I'm working on. What number can I put here that when multiplied by the subscript of 2 will give me 6? And obviously that's going to be a 3. So I put the 3 in there and I recount. The nitrogens didn't change, I still have 2. And now I have 6 hydrogens. So my reaction now obeys the law of conservation because I have 2 nitrogens and 6 hydrogens on each side. All right, for this one, we're going to quickly make our list: carbon, oxygen, and hydrogen. And on this side, we have carbon, oxygen, and hydrogen as well. I'm going to make a quick count: 1 carbon, 1 oxygen, 2 hydrogens, 8 carbons, 1 oxygen, and 20 hydrogens. Where am I getting that 20 hydrogens from? Well, let me get a little pointer and show you. There's 18 of them here, and there's 2 more here. So that hydrogen is in 2 places. So we really don't want to mess with those until the very end. So what I will do first is I will attack these carbons with this 1 and an 8. Working on the side that's lower, I'm going to go up to that carbon and I'm going to look, what number can I place here that when multiplied by this subscript of 1 is going to give me an 8? And I hope you will say that's going to be an 8. Soon as I do that, these numbers are meaningless. I recount: 8 carbons, 8 oxygens, and 2 hydrogens. All right, now let's work on the oxygens. And the reason I'm picking the oxygens is because I got 1 and 8, and the oxygens here are only in one place. One place here, one place there. Whereas the hydrogens are in two places, hydrogen, and then on this side there's only one place. So I really want to leave the hydrogens for last. So let's deal with the oxygens next. I'm going to go up to the oxygen that's on the product side, which is right here, and I'm going to place a number in front of that, which is going to give me 8 oxygens. So there's a subscript of 1, so I'm going to multiply 8 times 1, which will give me 8 oxygens. So let's recount the product side. 8 carbons, we've got 18 hydrogens, and we've got 16 hydrogens. That gives us a total of 34 hydrogens on the product side. And then for my oxygens, I have 8. Well, it's working out very nicely. Let's get out a pointer again. The 8s for the oxygen carbon match with the carbon and oxygen on the product side. So 8 and 8, 8 and 8. And then the hydrogens don't match. But this hydrogen's by itself, and I need a number that when multiplied by 2 will give me 34. And the only number that when multiplied by 2 that's going to give me 34 is going to be 17. So 17 is going to go there. I'm going to recount everything just to make sure. My carbons didn't change, my oxygens didn't change, but now I have 34 hydrogens. So there you have it, where our coefficients for this are 8, 17, 1. Whoops, I need a pen. You can't see what I'm doing. 1 and 8. All right, this one's a little bit trickier. We're going to take a look at this one. This one you have, I made the tally already. So let me get my pointer out. You got 1 iron and 1 iron, 4 oxygens, but only 2 on the product side, and 1 carbon and 1 carbon. So we must start with the oxygens. You'll see that the oxygens up here are in 2 different places. There's 3 here and 1 here. There's 2 oxygens here. If I change these oxygens, the carbon number is going to change, and we don't really necessarily want the carbon numbers to change. So what I'm going to do is I'm going to start playing with the numbers. I'm going to put a 2 here. I'm going to show you how if I can make myself crazy by going back and forth. If I put a 2 there, I get 2 carbons. I will now have 4 oxygens and 1 iron. Now my carbons are not matching, but as soon as I put a number in front of this, it's going to change the oxygen as well. Or if I put a number in front of this, it's going to change the iron. So we've got a big problem here. If I put a 2 here, just hear me out, and I recount, I have 2 irons, I have 3 oxygens over here, see where my pen is, and I've got 2 more, so I'm going to have 5 oxygens. Whoops, that's sloppy. And I'm going to have 2 carbons. So I'm really in a pickle because no matter what I do, if I change the oxygens, the carbons are going to change. If I change the carbons, the oxygens are going to change because the carbon and oxygens are attached to one another. So 2 is not the way to go. I'm going to erase this, and I want to, whoops, where's my eraser? I want to show you what would happen. Oh, that's a happy accident that it's locked there. If I changed this to a 3, if I change that to a 3 by taking iron, I'm leaving it as 1. Oxygen now is going to be 3 and 3 more, which is going to be 6. And I'm going to have 3 carbons. Okay, so let's just double check our math here. We got 1 iron, 3 oxygens and 3 more oxygens gives me 6 oxygens, and 3 carbons, that's 3 carbons. Now let's go to this side. The irons are still good. The oxygens don't match and the carbons don't match. So if I put a number here to get this number of oxygens to equal 6, what can I multiply by this 2 to get 6? And that's going to be a 3. And I'm going to recount and see how things go. So this is a 3. I lied. That's still a 1. The oxygen becomes 6 and the carbon becomes 3. Well, 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 look at that. Now, I'll get a pointer out again. We got 1 iron, 6 oxygens, 6 oxygens, 3 carbons, 3 carbons. So sometimes you kind of just have to play with the numbers a little bit. There is another way to do this, but it involves a lot more oxidation numbers and watching the charges of things. So sometimes just doing it by inspection, that's what we're doing here. By looking at it, you have to kind of finagle the numbers. And this is an example of that. All right, so in this one, there's another little trick that we have to look out for, and that is the fact that we can keep polyatomic ions as long as they show up on both sides of the equation. And here's SO4, which is a polyatomic sulfate ion, and a sulfate ion. We can keep them as one whole unit and count them by the number of units of SO4 that we have on each side. I also kept the OH, which is another polyatomic ion, a hydroxide ion, as a whole unit because it appears on the reactant side and it also appears on the product side. And you might be saying to yourself, where is that OH on the product side? So here's the trick. If you see an OH on the reactant side and you see an H2O on the product side, I want you to go ahead and change the H2O to HOH. When you do that, it's still 2 H's and an O, so it's still water, but now you can see the H and the OH independent of each other. So I'm going to go ahead and do that. Cross this off so you don't see it anymore, and I'm going to count. All right, so in this one we got 2 H's. Get out a pen. We got 2 H's. We've got 1 SO4 because this SO4 is traveling as a group. Lead is 1 and OH I have 4. On this side I have hydrogen now, which I have 1 of. I have an SO4, which I have 2 of. Lead, which is Pb, I have 1. And OH, I have 1. All right, let's go down our list and see what we can play with. We've got the hydrogens, which do not match. I strongly suggest you leave hydrogens and oxygens for the end. So what we'll start with is these SO4s because the leads already match. So what I'll do is I'll put a 2 in front of this SO4. All of these guys go away. I recount 4 hydrogens, 2 SO4s, 1 lead, 4 hydroxides. Now let's go to the other side. The sulfates match and the lead matches, so I have to address my hydroxides and my waters. Well, you'll see that they both are 4 here and 1 and 1 here. So if I take and put a 4 in front of this HOH and I recount, I got 4 hydrogens, I've got 2 sulfates, I've got 1 lead, and I've got 4 hydroxides. And now everything matches up nice and pretty. 4, 4, 2, 2, 1, 1, 4, 4. So the trick there was to change the water into an HOH. Okay, this one's pretty straightforward, at least I hope it is. The aluminums match, the hydrogens don't, and the chlorines don't. Leaving hydrogens, and if there were any oxygens, we'd leave those for last. So I'm going to start with the chlorines. I'm going to put a 3 here. Oh, I don't like that color. Let's put a 3 here. We're going to recount everything. 1, 3, 3. Well, that got my chlorines to match and my aluminums to match, but my hydrogens don't match. So I have to work on the smaller side. What number can I put here that when multiplied by the 2, which is the subscript, is going to give me 3? And that number is going to be 1.5. So when I do that, I've got 1 aluminum, I've got 3 chlorines, and I've got 3 hydrogens. Well, as we know, we cannot have half numbers as coefficients. So what we'll do to get rid of that is we'll double everything. So instead of a 1 that's here in the blank spaces, we'll make them 2. Instead of a 3, we'll make it a 6. We'll make this a 2, and we'll make this a 3. So our answer is 2, 6, 2, 3. All right, let's take a look at this one. I made a list of all of the things we have on the reactant side. We've got a calcium, we've got a phosphate, which is a polyatomic ion. It also appears on the product side, so we're going to keep it as one whole unit. That's one of our tricks that we have. We have hydrogens, which appear on both sides, and we have sulfates. So I made a list, and now I'm going to go ahead and I'm going to count them. So calcium, I have 3. Phosphate, I have 2. Hydrogen, I have 2, and sulfate, I have 1. Now on the product side, let me get a pointer so you can see what I'm looking at. This calcium and this calcium means I have 2 calciums. So I'm going to put a 2 there. I've got 1 sulfate, I've got 4 hydrogens, and I've got 2 phosphates. In this one, I'm gonna kind of break my rule just a little tiny bit because the calciums over here are a 2 and a 3. I could put a 1.5 somewhere and try to get that to be 3, but where do I put that 1.5? Because I have 2 calciums that I'm working with. So I'm gonna hope that by doing the hydrogens first, which I generally don't recommend. I recommend doing the hydrogens and oxygens last. But I hope by fixing those hydrogens, this mess up here, the odd and the even number, will work itself out. So I'm going to go ahead, I'll use purple. I'm going to put a 2 in front of that. I'm going to cross everything out and I'm going to recount. 3 calciums, the phosphates didn't change as well, the hydrogens became 4, and the sulfates became 2. Now, I've got 3 calciums still on the left, got 2 phosphates, I've got 4 hydrogens, but this changed now. This sulfate changed from a 2 and a 1. So instead of tackling the odd and the even, I'm going to tackle these sulfates. When I put a 2 in front of the calcium phosphate, I'm going to recount. And this is where the recounting becomes extremely important, because with the recounting here, you're going to see that these calciums are going to change. Let me get a pointer so you can see. 2 calciums here plus 1 more here gives me 3 calciums. Now, if you didn't recount them, you might have missed that. And then we've got 2 sulfates. That's good news. We've got 1 calcium here and 2 over there, so that doesn't change anything. We've got 4 hydrogens. That doesn't change. And we've got 2 phosphates. Take a look at what we have now. 3 and 3, 2 and 2, 4 and 4, 2 and 2. So we didn't have to attack these odd and even numbers by using the half trick. I was able to do it by making sure that everything else was balanced and praying that these fell into line. So that's another little strategy that you can use if you find out that you have a odd and even number. Now for this question, this is the last one on this page. In this question, we have PO4, which is a polyatomic ion. Let me get a pointer out right there. But it doesn't appear anywhere on this side of the equation. We have an H2O, which I could change to HOH, but it doesn't have an OH on this side of the equation. So none of those tricks are going to work for us this time. So I'm just going to break everything apart and pray for the best. So we've got 3 hydrogens, we've got 1 phosphorus, 4 oxygens, and 1 chlorine. Whoops, that little sneaky hydrogen. So this really is 4 hydrogens because there's 3 here and 1 there. I wasn't looking very carefully. Now we're going to do the product side. We've got 2 hydrogens, we've got 1 phosphorus, we've got 1 oxygen, and we've got 5 chlorines. All right, 4 and 2 don't match, but hydrogens I want to leave last and oxygens I want to leave last. We've got phosphorus matches and chlorines are 1 and 5. So that's where I'm going to start. I'm going to start with the chlorines. I'm going to place a 5 in front of the HCl on the reactant side, and I'm going to recount. 3 hydrogens here, pointer, come here pointer, 3 hydrogens here, and 5 more here gives me 8 hydrogens. We've got a phosphorus, we've got 4 oxygens still, and we've got 5 chlorines. Oh, hopefully that's easy to read. Okay, so we've now got the chlorines to match, the phosphorus match, we're down to hydrogens and oxygens. Which one should we do next? I think that we probably should do the, well, I guess it's not going to matter in this case, and you'll see why in a second. So if we do the hydrogens, leaving the oxygens for last, what number can I put in front of this H2O that when multiplied by this subscript of 2 is going to give me 8, and that's going to be 4. When I do that and I recount, I have 8 hydrogens, I've got 1 phosphorus, I've got 4 oxygens, and I've got 5 chlorines. And give yourself a smiley face because we just finished that awesome worksheet, right? That hydrogens and oxygens work themselves out. And that happens a lot. You just have to stick with it and give it a little bit of practice, and you'll be a pro at balancing these equations. Also, you just FYI, sometimes they don't call it balancing equations. They say Which of these following obeys the law of conservation of mass, or a law of conservation of matter, or law of conservation of charge, or blah blah blah, law of conservation, period? If they say that, what they're referring to is a properly balanced equation.